What's up, algebra class? All right. Today we are going to talk a little bit about exponents because we're going to move into exponential functions next. And I believe I talked about this, it was either this class or another one where I talked a little bit about exponents and how they work. But I'm just going to go over it again and go a little bit further. So we're all familiar with addition and multiplication, right? 3, that didn't work. 3 plus 3 is 6. So 2 3s are 6. So 2 times 3 is 6 because that's 2 3s. 3. Why is this being weird today? 3 3s is 9, which would be 3 plus 3 plus 3. Because it's 3 3s. That's how multiplication works, right? Multiplication is related to addition because it's telling you how many of that number to add together. Well, exponents are basically the same thing, only using multiplication. So 3 squared is 9 because it's telling you 3 times 3. So the 2 in your exponent in the squared just tells you how many times to multiply the base together. So 3 cubed is 27 because it's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 2 to the 4th would be 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Does that make sense? That's the basics of an exponent. In an exponent, you have a base and a power. A base and a power together make up an exponent. Another thing that you'll often see is you'll see a number before the base, like 6 times 2 to the 5th. This constant, when you have 6x to the 5th, we have our power, our base, and our constant. And the constant is called your coefficient, if I can spell that right, something like that. So you have your coefficient, your base, and your power. The exponent itself is just the base and the power. But you'll also see a coefficient before that a lot of times, so I just want to bring that up. Up until now, we've been talking about linear equations. Linear equations form a line when you graph them. So we've had what was that called again? Anybody remember? I'll leave that to you. That's a certain type of graph. Then we have a type of graph that goes like this. You should know what that's called. But these are all lines. And then we have a type of graph that goes maybe like this, something like that. And that is a type of graph that you guys should all know that we have talked about. And, you know, a regular line like the f of x equals x, right? So those are all linear equations. Erase that. Now, we're going to go a little bit into exponential equations. In other words, equations with exponents. These do not form a line because let's take a linear model, 2x plus 3. All right, we'll go 0, 1, 2, 3, 4, 5. 2 times 0 plus 3 is 3. 2 times 1 is 2 plus 3 is 5. 2 times 2 is 4 plus 3 is 7. 2 times 3 is 6 plus 3 is 9. 2 times 4 is 8 plus 3 is 11. 2 times 5 is 10 plus 3 is 13. So we're not going up all that quickly here. In fact, we're only going up by 2's because the coefficient is 2. The variable determines, or not the variable, sorry, the y-axis, the y-intercept over here, f of x equals mx plus b, slope x, y-intercept, right? When we form our line, your y-intercept determines where you start, and then your 2 determines how much you go up each time, and your x is just the number you're starting at. So you could do 20x plus 15, and you'd be going up by 20s starting at 15, right? When you do an exponential equation, f of x equals 2x cubed plus 4. Now we have 0, 1, 2, 3. We'll even be fair. We'll say plus 3. Because the last one was plus 3. 2x plus 3. This is going to be 2x plus 3. 4. Alright, so 2. We have 0 cubed. 0 times 0 times 0 times 0 times 0 times 0 times 0. It doesn't matter. It's going to be 0. So 2 times 0 is 0 plus 3. We're starting at the same place we did last time. Our y-intercept is still 3. 2 times 1 cubed, well, 1 times itself, it don't matter how many times, it's still going to be 1 plus 3 gives you 4. But wait, we only went up by 1. Last time we were going up by 2's. How is this better? Well, 2 cubed, 2 times 2 times 2 times 2 is 4, times 2 is 8. 2 times 8 is 16, 17, 18, 19. Boom! That's a big jump. Then let's do 3. 3 cubed, as we talked about earlier, 3 times 3 is 9, times 3 is 27. 2 times 27 is going to be, let's see, that's 14, 2 times 4, so 54, plus 3 is 57. All right. So when you graph this, rather than a line, you are going to get, let's see, the y-intercept is 3, so it's right there. It starts going up kind of slowly, but then it ramps up really quick. So that is what our exponential equations look like. And when I say better, I'm talking about in certain instances, like money. Would you rather have a linear gain of money or an exponential gain of money? What? I'll take the exponent, thank you. All right, so that is our basics on what exponents are, how they work, and the difference between graphing an exponential equation and a linear equation. That's it, just the basics. Thanks for your attention. Love you guys. Bye.